Today's lesson is on modeling with exponential functions. Amber buys a car for $17,500. The car depreciates 8% each year. Write a function that represents this function. All right, so recall that a function that depreciates loses its value. So in general, it loses its value over time. And in this case, we know her initial buy or purchase for the car was $17,500, so that would be A. And part of the formula is 1 minus, and the rate is 8%. So you can write that as a decimal as 0.08. And over time, T represents the time in years. So this will be the function. Or in this case, f of t, I should say. Because t, you're going to input the time for t. What will be the value of Amber's car after 10 years? All right, so you're going to take this function, f of t, that we had previously, and you're going to evaluate t for 10. So what they're asking is this: after 10 years, what's the value of Amber's car? And all you do is this: 1 minus 0.08 to the 10th power. And the rest is order of operations. You're going to take care of the parentheses first. That should be 0.92 to the 10th power. You take care of that first, and then you're going to multiply that by 17,500. And if you do that correctly, you should get roughly about $7,601 is what the value of her car is going to be in 10 years. Complete the table. We have time in years and the value of her car. So, you remember our function is f of t equals 17,500 and 1 minus 0.08 to the t. And if t is 0, remember the exponent rule is if anything's raised to the 0 is 1. So you just get 1,700 times 1, which makes sense because if there's no years on the car, it's going to be the initial value that she purchased it. But after 1 year, if you plug this in, you're going to get, you have to multiply this times, and this is 0.92. To the first power is just 0.92. And if you multiply that, you're going to get 16,100. And if you go through the chart, you're going to get these values. Then it's going to go down to 14,812. After 3 years, it's going to go down to 13,627. And after 4 years, it's going to go to 12,536. All right, graph Amber's situation. So the y coordinate is going to represent the value of the car in thousands of dollars. So this represents 3,000, 9,000, 15,000, 21,000, 27,000. These numbers here on the x-axis represents the number of years. In this case, this will be the t. And this will be f of t. So you're talking about 0 years, 1 year, 2 years, 3 years, 4 years, and so on. So, according to the chart, initially, it was 17,500, so that's going to be roughly in here. I counted up by threes, so it'll be here. A little below 18. And the first year is going to go down to 16,000. So it's going to be roughly here. And in 2 years, it goes down to 14,000. 3 years, it goes down to 13,000. So it'll be roughly there. And in 4 years, it goes down to 12,000. So that'll be here. So the pattern is it's going to depreciate. It's going to steadily go down. An online music sharing club has 5,060 members. The membership is increasing at a rate of 2% per month. In approximately how many months will the membership reach 10,000? Okay, this is an exponential growth function. So we're saying f of x is going to equal a, and this is going to be 1 plus the rate raised to this particular power. So we know that A is going to be the current members in the group. So we got 5,060. And the rate that's growing is 2% per month. So we're going to put 0.02. And but what we don't know is in how many months will the membership reach 10,000. So we don't know that. That's what we're trying to figure out. So you got to set this equal to 10,000. And if you solve this, you're going to divide this, both sides here, by this number here. That's going to give you roughly 1.976. And if you add 1 plus 0.02, you get 1.02. This is raised to the x power. Multiply 1.2 that many times will give you 1.96. And that number should be 34. If you have your calculator, that's going to be approximately 1.96. So we're going to say about 34 months. This concludes our lesson for today.